Problem 21. The function g is defined as follows. G of x is equal to x squared minus 2x over x squared minus 4. Part A. Use a table of values to estimate the limit as x approaches 2 of g of x, accurate to 3 decimal places. Show the work that leads to your conclusion. Okay, if it asks me for a table of values, I'm going to do a table of values. And I need to do things close from the left getting to 2 and then to the right. So coming in from the left, I'll have 1.9. and then 1.99, and then 1.999. Again, of course, I can't plug in 2 because that will give me an undefined answer. But then I can use 2.001, and then 2.01, and then 2.1. So that's what I'm going to plug in for my x's. And when I do that, I found that when I plugged in 1.9, I got 0.48718. 1.99 was 0.49875. 1.999 was 0.49987. When I plugged in 2.001, I got 0.50012. 2.01 was 0.50125. And then 2.1 was 0.5122. So as I'm coming in from the right, and as I'm coming in from the left, I notice that they are approaching, it looks like 0.5, and since it needs to be accurate to 3 decimal places, my limit will be 0.500. Okay, part B says to find the limit analytically, so that means using algebraic methods. So I'm going to have x squared minus 2x over x squared minus 4. I notice that if I try to plug in 2 right now, I'm going to get 0 over 0. So that means I just cannot plug in 2 yet. So I'm actually going to factor. So in the numerator, I'm going to factor out an x, so I'll get x minus 2. In the denominator, that's a difference of squares, so I'll get x plus 2 times x minus 2. Then I notice I can cancel out the x minus 2's, so I'm left with x over x plus 2. And then my whole goal was to be able to plug in 2, so now I can plug 2 into my function. I'm going to get 2 over 2 plus 2, which equals 2 over 4, which reduces to 1/2. So that would be my limit, and notice I did get the same answer for both parts. All right, part C, show that g of x is discontinuous at x equals -2. Use the conditions of continuity to support your conclusion. Okay, before I do that, I'm just going to review. Condition 1 was that f of -2 is, actually this would be g of -2 is defined. Okay, my second condition would be that the limit as x approaches -2 exists. And then the third condition would be that g of -2 is equal to the limit as x approaches -2. Okay, so as long as I can show it's discontinuous by showing that any one of these doesn't work. So I'm just going to start with condition 1, g of -2 being defined. Well, if I try to plug -2 into this equation, I get an undefined answer. So I can right away say that it's discontinuous. I can say that g of x is discontinuous because g of -2 is undefined. Okay, if you didn't happen to see that, what we could do on this one, if I could show that the limit exists or does not exist, we'd actually on this one, if we graphed it, notice actually on this one where I'm not looking, this was x equals 2 and I'm looking at x equals -2, so don't be confused. This is what the graph looks like. Looks something like that. So the second thing that I would look at is if I was finding the limit, I'd have to find the limit from the right and the limit from the left, and notice the limit from the left is infinity and the limit from the right is -infinity. So my limits from the left do not equal the limit from the right. So I'm just going to put also because the limit as x approaches -2 does not exist. And again, that was because my limit from my left did not equal my limit from the right. So either one of those would be fine. And I guess you could say condition 3 also because the two do not equal each other as well.